In this video, I'm going to work out 8 problems. They're all simplifying radicals. I'm going to start with an easy problem and eventually get up to some harder problems, including fractions and when you have a negative under the radical sign. So let's get started. This one is the square root of 75x. The very first step every time we simplify radicals is to make a factor tree. So 75 is 3 times 25. And then we can break 25 down as 5 times 5 and bring the 3 down. And go ahead and just write out the x as well, the variable. Okay, now we've talked about in class I've told you about this prison break story, about because this is a square root, we can only take out factors that are exactly the same and there's 2 of the same factor. And so these 5s together make a 25, and that's a perfect square number. And so the square root of 25 is 5, and that leaves on the inside of the radical the 3 and the x, which are not perfect square numbers, and so those remain inside the radical, and 5 times the square root of 3x is your answer. All right, on this one, we're going to do the same thing, except I want to point out to you that there is already a number on the outside of the radical. First thing I want you to do is make a factor tree. This is 8 times 9, break 8 down to 4 times 2, 9 breaks down to 3 times 3. We can break 4 down one more time. It's 2 times 2 times that 2 times 3 times 3. This is called the prime factorization, this bottom row that I'm putting a square around. Okay, next, to figure out the numbers that go on the outside of the radical and those that stay on the inside of the radical, I want you to identify pairs of the same number. So we have 2 2s and 2 3s. Now, what this means, 2 2s, that's 4, and we know the square root of 4 is 2. 2 3s, which is 3 times 3, is 9, which we know the square root of 9 is 3. It's almost if, and I don't know if this will be confusing or not, it's almost if we could say the square root of 4 times the square root of 3 times the square root of 9. That's what we've done here with this prime factorization. We know the square root of 4 is 2. We know the square root of 3 is some small decimal, so we'll keep it as square root of 3. And we know square root of 9 is 3. And so when you multiply those together, you have 6 square roots of 3, because outside numbers multiply with outside numbers. But this problem, I don't want you to forget, remember this 2 from the original, that needs to be multiplied by the 6. So the final answer is 12 times the square root of 3. All right, let's take a look at this problem. This is the square root of 64a cubed b to the 6. Okay, so when you're asked to simplify, that's when you go right into a factor tree. This is 8 times 8, which you could stop there, but I'm going to go ahead and go all the way down to the prime factorization. Okay, so here we have how 64 breaks down into prime factors. With these variables, I want you to write out 3 a's and then write out 6 b's. So all we've done, all of these numbers, I've just broken down 64a cubed b6 into these individual factors. All of this is still, and this might get a little sloppy, all of this is still under a big radical symbol, because we've not done anything to the original radical up here. All we've done is break down 64a cubed b6. Okay, so from now, we're going to identify perfect square numbers, and what that really means is you're going to identify twins or pairs of numbers that are the same numbers. So we have 2 2s, 2 2s, and 2 2s. We have 2 a's, b's, b's, and b's. So almost everything was circled. So now all of this is still under the radical, but I want you to notice that the square root of 64 is 8, and when we take back to this prison break story, and if you're watching this video and you have no idea what I'm talking about when I talk about a prison breakout story, please send me a message. I will tell you the story. With each group of 2s, pairs of numbers, only one survives. And so 1 2 survives. With each pair of numbers, only one survives. So 1 2 survives, a 2 survives from this group, a 2 survives from this group, a single A, and then 3 of these B's survive. So here's what that looks like. On the outside of the radical, you're going to have 2 times 2 times 2 that represents each of the 3 groups of 2, A, and then instead of writing B, 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 I just want you to write a single letter B and then put a 3 down for an exponent. Redraw your radical because that A did not have a partner, and so it could not leave from under the radical. So you need to put that A back. The last step that I want you to take is to multiply this outside together. 2 times 2 times 2 is 8, and then your variables are going to stay the same, A B cubed times the square root of A, and that's your final answer. Okay, take a look at this problem. This one is just like the one before, so I'd love for you to stop the video and try this one on your own. The only thing I want to point out that's different is that there is a number here on the outside of the radical that you need to make sure to multiply through when you are writing out your final answer. So go ahead and pause the video and work this out on your own and then catch up with me. Okay, so here I have made my factor tree. Now I'm just ready to circle the pairs of matching numbers. And so notice that I have matching 2s and I have these matching 3s. I have a pair of matching X's, B's, B's, and C's. Something interesting just happened here. Everything got circled. Okay, so let's first talk about what got circled. And remember how it goes. With each pair that was circled, only one number survived. So we had a pair of 2s, we had a pair of 3s, a pair of X's, a pair of B's, another pair of B's, and a pair of C's. Together, that looks like 6. So this is what you have when you multiply those together. But let's not forget that there was a 5 already there. And so 5 times 6 is 30 xb squared c. All right, let's talk about the radical sign. All of these numbers were under the radical, but notice that all of them were circled. There's not a single number left over. And so when you have a case like that, you do not need to draw the radical symbol at all. What we're working with is a perfect squared number. 36 x squared b to the 4th c squared just happens to be a perfect square number. So you do not need a radical at all. You don't need to put a radical 0. You don't need to put a radical 1. You're just going to write this 30x b squared c for your final answer. This one is the cubed root of 162, a to the 6th, y to the 4th. I want to point out to you that we're now working in a cubed root. So after we make the factor tree, we will circle groups of 3 matching numbers. Okay, so first thing, go ahead and you can pause the video and sketch out the factor tree. As you can see on the screen, I have done my factor tree. I chose to start with the factors 2 times 81, and then I broke 81 down. I listed out 6 A's and 4 Y's. Okay, here's when it's going to be really important to pay close attention to the problem. Like I just said, we are in cubed roots, and so now I can only circle groups of matching, we'll call them triplets. They have to be the same number, has to be 3 of them. Here's a group of 3, a group of 3, a group of 3, and a group of 3. Okay, for each group of 3, we represent that group by putting one of those numbers outside of the radical. So if we go back and draw our cubed root, we are going to put a single 3 outside the radical to represent that group. We are going to put an A with an exponent of a 2 to represent those 2 groups, and then a y. Next, I want you to recognize what did not have a group of 3. What did not have a group of 3 was a single 2, a 3, and a y. 2 times 3 times y is 6y, and that's your final answer. Okay, these next 2 are going to be fractions. We'll get more into fractions under a topic called rationalizing the denominator. What you need to know about fractions and radicals at this moment is that it's improper to leave a radical in the denominator. It's okay to have a radical in the numerator, but not in the denominator. And we'll, like I said, we'll practice more of that in another topic here soon. But what I want to show you is just very, very basic fraction problems. The first thing I want to point out to you is that when you have a large radical over an entire fraction, it is the same as two radicals, one radical in the numerator, one radical in the denominator. Okay, so big radical equals two small radicals. And then what you have on is just two separate problems. We are going to make a factor tree with the square root of 66 and a factor tree of the square root of 49. So it's working two problems within one problem. Go ahead and make your factor tree. You can pause the video. Make your factor tree for both 66 and 49. Okay, you can see my factor trees. 66 broke down to 2 times 3 times 11, and 49 broke down to 7 times 7. Hopefully you recognize that the square root of 49 is 7. So instead of having square root of 49 in the denominator, we're going to replace the square root of 49 with the number 7. Now over here, the square root of 66, it seems like 66 would be a large enough number to, find a set of matching numbers, but there's not. The 2, the 3, and the 11 are single factors. They don't have a match. And so we're going to simply just leave the numerator the same. And y'all, this is as far as this problem can go. All right, let's take a look at one more fraction. This one is already divided into two separate radicals. And so I want you to follow the same pattern that we just did. I want you to take a moment and do a factor tree for the square root of 48 and a factor tree for the square root of 64. Pause the video. Okay, here's your factor trees. Because these are both square roots, we are now going to go and identify matching pairs of numbers. So for the square root of 48, you have a pair of 2's and another pair of 2's. And then for 64, you have 3 pairs of 2's. Now, it's okay to stop right here. This is actually where I want you to stop eventually. I want you to recognize that 64 is a perfect square number. And so if you recognize that, you don't have to do the entire factor tree. It's not going to hurt you to work out the factor tree because as long as your factors are correct, the answer will be the same. But as you can see here, 2 times 2 times 2 is 8, which is what we would have had. Okay, so the first thing we're going to do the denominator since it worked out so easily. Another way to write the square root of 64 is just to write the whole number 8. All right, let's go back to the square root of 48. Remember, with each of these groups, we're only going to represent one number from each group. And so we have a 2 and a 2, which is 4, times the square root of 3. One last step, which we didn't have to do with the previous fraction problem, but when you have two outside numbers outside the radical, it is okay to reduce these the same way you would reduce a regular fraction. So 4 goes into 8 twice. And so the most simplified answer is the square root of 3 over 2. Okay, this brings us to our final problem. I want to point out to you that this is a cubed root again. And this one has a negative under the radical. Because this is a video and I don't want to get this video super long, what I'm going to tell you right now about this negative is that if the index number is odd, and that little 3 is your index number, it is okay to have a negative under the radical, and you're simply just going to bring that negative to the outside. Okay, that's what I'm going to say about right now. That's a very incomplete explanation, but I can provide more detail on that if you need it. Okay, go ahead and pause the video and write out the factor tree. Okay, so here's your factor tree. We had a lot of 2's come out of this. Remember that we are circling groups of 3. Here's a group of 3, a group of 3, and a group of 3. All right, so now when we go to do our answer, go ahead and draw back the cubed radical symbol, and let's go ahead and mark that this is going to be negative. We circled 2 groups of 2, and so we're going to represent it with just 1 2 per group, and so 2 times 2 is 4, and then we had a single B. Inside the radical, the numbers that did not have a group of 3, those remain under the radical, and so the final answer is negative 4b times the cubed root of 2a. That's it for this video. Please ask me questions if you're still unsure. There's lots of resources on Moodle, lots of resources on YouTube, but please don't hesitate to contact me and I will gladly explain more problems to you. Thanks for watching.